In this video, we'll be working through problem 2 of the May 2019 Math CXC exam. In part A, we're asked to simplify some expressions. For the first one, we have 3p squared times 4p to the fifth. Well, the first thing that we can do is group all of the numbers together and group all of the p terms together. I can write this as 3 times 4 and then times p squared times p to the fifth. Now what we can do is combine the exponential expressions p squared and p to the fifth. Remember that we have this exponential rule. If I have x to the a power times x to the b power, these can be combined together by adding the exponents. It would be x to the a plus b. So we're going to do something similar here. First of all, I can combine the 3 and the 4 together to get 12. The p squared times p to the fifth will give us p to the 2 plus 5, according to our exponential rule. Then adding the 2 and the 5 together, we end up with 12p to the 7, and that's our final answer. In part 2, we have 3x over 4y cubed divided by 21x squared over 20y squared. The first thing we're going to do here is rewrite the division as a multiplication by the reciprocal. So I want to think about this as 3x over 4y cubed, and again, instead of dividing, I'm going to multiply by the reciprocal of that second fraction. That's 20y squared divided by 21x squared. Now let's simplify the numerator and denominator. Now let's combine the fractions and simplify the numerator and denominator by grouping some of the terms together. So this is going to give us 3 times 20 times x times y squared divided by 4 times 21 times x squared times y cubed. Now to simplify some of the numbers, what I can do is factor. I have 3 times 20 I can rewrite as 4 times 5. And then I have times x times y squared divided by 4 times the 21 here I can rewrite as 3 times 7, and then times x squared times y cubed. So notice that we have 3 as a common factor in both the numerator and denominator, so those will cancel out. And similarly, the 4 will cancel out because that's a common factor in both the numerator and denominator. Now let's try to simplify the variables, x over x squared and y squared over y cubed. The exponential property that we want to remember here is that if I have x to the a divided by x to the b, this can be rewritten as x to the a minus b. Or alternatively, we can write this as 1 over x to the b minus a. And that second way of rewriting it is what we're going to do. We're going to move things to the denominator, and when we do that, we're going to subtract the exponents. So moving our variables to the denominator, we have 5 in the numerator divided by 7 times x to the 2 minus 1 times y to the 3 minus 2. I'm subtracting the exponents, which simplifies to 5 over 7 times x times y. And that's our final answer. In part B, we're asked to solve the equation 3 over 7x minus 1 plus 1 over x equals 0. The approach I'm going to take here is to multiply by the least common multiple of the denominators. When I do that, I'm going to get rid of all of the fractions. In this case, the least common multiple of the denominators is the product of the denominators. So I'm going to multiply the left-hand side of this equation by x times 7x minus 1. And whatever I do to the left-hand side, I also need to do to the right. So I'm going to multiply the right-hand side by x times 7x minus 1. When I distribute the x times 7x minus 1 to the sum of fractions, I'm going to get x times 7x minus 1 times 3 over 7x minus 1 plus x times 7x minus 1 times 1 over x equals 0 times x times 7x minus 1. And since 0 times anything is 0, I just end up with 0 on the right-hand side. Now to simplify the left-hand side, I'm going to cancel out some common factors. In my first fraction, I have a common factor of 7x minus 1 in the numerator and denominator. In my second fraction, I have a common factor of x in both the numerator and denominator. Once we've canceled, we're left with 3x plus 7x minus 1 equals 0. Combining the like terms here, 3x plus 7x, that gives me 10x minus 1 is equal to 0. Add 1 to both sides to get 10x equals positive 1. Then lastly, divide both sides by 10. We have x equals 1/10. And that's our final answer. In general, when you have equations involving fractions, it's a good idea to check if your solution actually works in your original equation. You need to make sure that when you plug in your x value, that you're not dividing by 0. So, for example, if I plug in x equals 1/10 into this denominator here, I'm not going to be dividing by 0, so that's okay. If I plug in x equals 1/10 into this denominator, I have 7/10 minus 1, which is negative 3/10. Again, that's not equal to 0, so I'm all right. So x equals 1/10 is the correct answer. In part C, we are told that when a number x is multiplied by 2, the result is squared to give the new number y. In part 1, we're asked to express y in terms of x. So let's follow the operations. We start off with a number x. It says we're going to multiply it by 2, then square the result. And then the resulting thing is the number y. So I have 2x squared is equal to y. Let's simplify this a little bit. I can write this as y equals, then distributing the square to each of my factors, I have 2 squared times x squared, or 4x squared. So that's my final answer. In part 2 of this problem, we're asked to determine two values of x that satisfy the equation y equals x and the equation derived in part 1. Okay, so my two equations I want to solve for is y equals x, and the equation from part 1 is y equals 4x squared. So we want to solve this system of equations. To solve this system, I'm going to substitute y equals x into the second equation. So I can write this as x equals 4x squared. Since I have a quadratic, the approach that I want to take to solve this system is to get everything on one side and then either use the quadratic formula or try to factor. So subtracting x from both sides, we have 0 equals 4x squared minus x. And this equation factors. I noticed that on the right-hand side, both of those terms have a common factor of x, so I'm going to pull that out, write this as x times 4x minus 1. Now, if the product of two things equals 0, then either the first factor equals 0 or the second factor equals 0. So here we have the product of x times 4x minus 1 equals 0. So that tells me that either the first factor equals 0, that's x equals 0, or the second factor equals 0, that's 4x minus 1 equals 0. Well, if x is equal to 0, that already gives me one of my solutions. To get my other solution, I'm going to solve the equation 4x minus 1 equals 0. So I'm going to add 1 to both sides, giving me 4x equals positive 1, and then dividing by 4, I get x equals 1/4. So my two solutions are x equals 0 and x equals 1/4. So that's it for problem 2 of the May 2019 CXC Math exam.